Walk over to your washing machine and look at how you tell it what to do. If it has a dial, a solid knob you pull and turn until it clicks onto the cycle you want, you may be standing in front of a machine that will outlive almost everything else in your house. But if it has a touch panel, or a row of soft buttons and a little screen, then the single part most likely to end that machine is not the motor, and it is not the drum. It is a circuit board about the size of a paperback book, and the engineers bolted it into the worst possible place for a piece of electronics to live. Here is a sentence that thousands of people have written online, in one form or another. No electronics in it, all mechanical, one service call in 25 years. Tonight I am going to explain exactly why that sentence is true, and why your new machine cannot say the same. Let me be careful and calm about this, because there is a lazy version that just yells the word computer, and that is not good enough. I want to show you the actual engineering. Start with the part that used to run the show, the mechanical timer. If you have ever turned that dial, you have felt it. Inside that housing is a small wind-up motor slowly turning a stack of shaped cams, and as those cams rotate, they open and close electrical contacts in a set order. That is the entire cycle: fill, wash, drain, spin, written into the shape of metal cams. It is not smart. It cannot weigh your load or sense a thing, but it is almost unkillable because it is just metal moving metal, and it does not care in the slightest that it is living inside a hot, wet, shaking box. Now here is what replaced it. On a modern washer, that timer is gone, and in its place sits an electronic control board, a green circuit board covered in tiny components, a small computer chip, and a bank of relays that switch the real power to the pump and the motor and the valves. On a lab bench, that board is a wonderful thing. It can run a dozen cycles, sense the load size, talk to your phone, and do it all for pennies once you are stamping out millions of them. And that last part, the pennies, is a big piece of why the swap happened. A precision-geared timer is a real mechanical object that costs real money to build. A control board, made at scale, is cheaper, and it unlocks all the features that sell the machine on the showroom floor. So from the maker's side, the board is an easy win. But now put that delicate green board back where it actually has to live, and watch what happens, because this is the whole story. A washing machine is, by design, one of the most hostile environments in your house. It is full of water and steam, so the air inside the cabinet is warm and damp, and moisture is the ancient enemy of electronics. It shakes violently, especially on the spin cycle, and that constant vibration slowly works cracks into the soldered joints that hold the board together. And it draws a big jolt of power every time the motor and the heater kick on, which means the board is riding out electrical surges over and over for years. Humidity, vibration, and power surges. If you sat down and tried to design the perfect way to kill a circuit board, you would build a washing machine around it. If you have ever suspected that the computer was the thing that killed your washer, then subscribe to Still Running, because putting the blame exactly where it belongs, on the specific part and the specific reason, is the entire purpose of this channel. Now let me connect this to the number that started us off, because the difference in lifespan is not subtle. Industry data now puts the average washing machine at somewhere around 10 to 12 years, and Consumer Reports, in a survey of more than 100,000 washers, found that roughly 1 in 5 of them broke or stopped working within about a decade of ownership. 1 in 5 within 10 years. Now set that next to the machines people brag about, the all-mechanical sets that ran 20, 25, even 30 years on 1 or 2 service calls. That is not a rose-colored memory. It is the direct result of what was running the machine. A cam timer in a metal case shrugs off the heat and the shaking and the surges. A circuit board does not, and when it finally gives out, it very often takes the whole washer with it, because a dead brain cannot run a healthy body. Here is the re-hook, the thing to hold on to through the rest of this. The old washer did not last because they used some secret steel we have forgotten how to make. It lasted because the part that controlled it was mechanical, and mechanical things tolerate a wet, shaking, surging home in a way that delicate electronics simply do not. We did not make washers smarter and keep them just as tough. We traded the toughness for the smarts, and almost nobody was told that was the deal. And the economics of the failure are what really sting. When that control board dies, you are not looking at a cheap wear part. A replacement board can cost a serious fraction of what a new washer sells for, and then you add the service call to diagnose it, because a board failure can look like a dozen other problems. So a repairman stands in your laundry room and gives you the same speech you have heard about every other modern appliance. The part and the labor come close to the price of a new one, so you might as well replace it. And out to the curb goes a machine whose motor, drum, and frame were all still perfectly sound, killed by the one part that was added to make it clever. And the control board is really only the beginning of the electronics they added. To feed that board, they also added sensors, a pressure sensor, to read the water level, sometimes a load sensor, a temperature sensor, and an electronic lid lock that has to report back before the machine will even agree to start. Every one of those is another small part, another connector, another wire living in a wet and shaking box, and any one of them failing can stop the whole machine cold or throw an error code that sends a perfectly healthy washer off to the repair shop. The old dial machine did the very same jobs with a simple float and a mechanical lid switch. Parts so dumb and so rugged, they almost never failed at all. We did not just add a brain to the washing machine. We added a whole fragile nervous system for that brain to worry about. You can hear all of this directly from the people who work on these machines and the people who own them. One former Sears technician put it as plainly as it can be put. The less computer parts a washer has, he said, the longer it lasts. Full mechanical washing machines last much longer. Another owner, describing an old all-mechanical Kenmore set, wrote that in 25 years, they had needed exactly one service call, and that the technician told them never to get rid of the machines. And a whole chorus of people keep saying the same simple thing in different words. I love the old turn-the-knob washers. Everything about them was better. They are not being nostalgic for the styling. They are remembering what it felt like to own a machine that just worked, for decades, without a fragile brain waiting to strand it. And here is the part that makes a board failure so maddening. When it goes, it rarely announces itself cleanly. A dying board can look like a bad pump, a stuck lid lock, a motor that will not spin, or a machine that fills with water and then just sits there. So you can spend real money chasing the wrong part before anyone figures out it was the brain all along. A mechanical timer, when it failed like a mechanical thing, in an obvious and traceable way, and any competent tech could put a finger right on it. The circuit board hides its own death behind a dozen false symptoms, and that alone can turn one repair into 3. So what do you actually do with this knowledge? First, if you own one of the old dial machines, understand what you have, and think hard before you replace a working one just because it looks dated. That machine may have another decade or 2 in it, and its parts are simple and cheap. Second, if you are shopping, know that you can still buy washers built around simpler, more rugged controls, including commercial-grade machines meant to survive years of hard use, and they are often the plainest-looking ones on the floor. Third, when a salesman walks you toward the model with the biggest touchscreen and the longest list of cycles, just remember where that screen has to live, and ask yourself whether you are buying a better washing machine or simply a more fragile one with a nicer light show. And think about it this way when you weigh those features. Every cycle, every sensor, every bit of phone connectivity they list on the box is real, but each one of them also rides on that same board, in that same wet and shaking cabinet. The features and the fragility are not two separate things you get to choose between. They come bolted to the same green card. So when you pay more for the smarter machine, you are very often paying extra for the exact part most likely to end it early. That is a strange bargain once you see it clearly, and the whole showroom is arranged so that you never quite do. I am not telling you that every electronic washer is garbage, and I am not telling you to fear a circuit board. I am telling you something more precise and more useful. The part that fails first on a modern washer is usually the control board, and it fails first because it was placed in an environment of heat, water, vibration, and electrical surges that is brutal to electronics and easy on a mechanical timer. The old machines were not blessed. They were just built around a controller that could take the punishment. Once you see that, the whole mystery of why your washer died so young quietly disappears. If you want more of these machines opened up and their real killers named, then subscribe to Still Running. Then go turn that old dial one more time, feel it click into place, and understand that the simple, stubborn sound is the sound of a machine that was built to survive its own laundry room.